Hello, welcome to Spy Math. This is Mrs. Spy, and this will be part 2 of my series on logarithms, on how to find a domain, and asymptotes, including how to find the x and y intercepts of a logarithmic function when they exist. On to the introduction to this lesson. How to find a domain and logarithm of logarithmic functions and the vertical asymptote. For this lesson, we'll have two examples. F of x equals log base 3 of 3x plus 4, and g at x equals natural log of x minus 5 plus 2. I can say at x, just as a note, instead of x, because when I have taught calculus in other classes, it confuses students less. So I'm going to say f at x instead of f of x, like most students are used to. Now on to the lesson. Okay? To find the domain, you set the part inside the parentheses I've highlighted greater than 0, and to find the asymptote, we set it equal to 0. So let's first do the domain. So you have 3x plus 4 is greater than 0. You solve for x in this inequality, so you have minus 4 on both sides. You get 3x is greater than negative 4. Divide by 3. You get that our domain is when x is greater than negative 4/3. Do the same thing to find the asymptote, but this time you set it equal to 0. You solve the same exact way. So our line for our vertical axis x equals negative 4/3. Remember, an asymptote is a line. So x equals negative 4/3, and the domain is x is greater than negative 4/3. You also could find the x-intercept. It's when this equation is equal to 0. So you set our equation equal to 0. The log of base 3 of 3x plus 4 equals 0. You rearrange it, that 3 to the 0 equals 3x plus 4. Anything to the 0 power is 1. So 1 equals 3x plus 4. You solve for x, minus 4 on both sides. 1 minus 4 is negative 3, so 3x equals negative 3. Divide by 3. X equals negative 1. So our y, our x-intercept is negative 1, comma 0. Remember, the x-intercept and y-intercept are points. This is finding the how to find the x-intercept. On to the next one. Okay, same thing here. You set the part x minus 5 in parentheses 2 greater than 0 and equal to 0. You solve these equations for x. You add 5 on both sides. You get a domain x has to be greater than 5. And the vertical asymptote is at x equals 5. To find the x-intercept, you set the equation equal to 0. So natural log of x minus 5 plus 2 equals 0. You minus 2 on both sides. You get the natural log of x minus 5 equals negative 2. So e to the negative 2 equals x minus 5. You add 5 on both sides. X equals exactly 5 plus e to the negative 2, which is approximately 5 plus e to the negative 2, approximately 5.135. 5.135. If you want to see some of these things on the calculator, let's pull up our calculator. Let's first show you how to find that x value. So second quit, you have 5 plus e is second division sign raised but above the division sign to the negative 2. You get 5.135. That does not look like that. Actually, it's like 51. So it's 5.135. Okay. We'll also look at the graphs of these functions. So we'll look at the graph of natural log of x minus 5 plus 2. And you also want to graph the intercept and the asymptote. So let's graph the asymptote at, can't graph that because it's a vertical line. That'd be interesting if we could. Not this program, but there's other programs that can't do it. So I'll show you in a minute. And that's your graph. It does continue straight down here. So if we zoom in, right over here, see that it does continue, which you don't see. And I'll just pull a better video using Desmos. Hold on. Okay, now using Desmos, we can actually see the asymptote. So the natural log of x minus 5 plus 2. So scroll over, this is the graph in red. And below it, I'm going to graph the asymptote. So x equals 5. You see that's a blue line. They look like they touch, but as you zoom in and they get closer, that red line gets closer and closer to the blue line, but never actually touches. The more you zoom in, the closer and closer it gets. And that's what an asymptote does, but it never actually crosses it. And if we scroll up, you'll notice that we have our intercept right here at 5.135, and there is no x-intercept. There is an x-intercept in this case, but there is no y-intercept at all, because if there was a y-intercept, that means value for x would have to be -5, and 5 is our master of our domain. Now let's go to a case where you could find the y-intercept. So a case of where you can find the y-intercept when it exists. Doesn't always exist, so you set the x value equal to 0 and solve. So f at 0 equals log of base 5 of 0 plus 3 minus 5. So you get log of 5 of 3 minus 5. You put this value into the calculator to get what it is to the nearest thousand. So log base, so alpha window, option 5, log of base 5 of 3, take away 5, you get negative 4.317. The value is negative 4.317. So this intercept is the point 0, comma, negative 4.317 approximately. Remember, the intercepts are always points. And to illustrate this on the graph, okay, so now you graph this function, log of base 5 of x plus 3 minus 5. Desmos can't let you graph log of any base but 10, so you set it up as a change of base form, log of x plus 3 over log of 5 minus 5. And you'll notice that our y-intercept is exactly what we said it was, at negative 4.317. That's it of finding the domain, asymptotes, x and y intercepts of logarithmic functions. In the next video, we'll explore the logarithmic laws. Thank you. This is Mr. Spy, signing off.